Okay, let's look at number 6 on page 162. The equation that we're dealing with here is x equals the sine of y. And the question wants to know, what is dy dx? Okay, so the equation as it's written right now is an implicit function in that it is not y equals. If it were y equals, we'd be able to do something with it. But as it is right now, I wonder if that's going to go away. All right. As it is right now, we can't. We could solve this for y, turn it into something that looked like this. If x is the sine of y, then y is the inverse sine of x. But that doesn't really help us either because we don't know how to do the derivative of the inverse sine, the arc sine of something. We know the derivative of sine, but not the inverse sine. So that doesn't really help us. But we can still find the derivative, dy dx, by doing implicit differentiation on the original equation. And here's what that would look like. So we're going to take the derivative of the entire equation, x equals sine y. The derivative of x is 1. The derivative of the sine of y, think of this as if it were a chain rule, where f is the fact that we're taking the sine of something, and g is some function that gets plugged into the sine. What are we plugging into sine? We're plugging in y. So whatever that function y is, that's what we'll call g. F prime, the derivative of the sine of x, is the cosine of x. G prime, then, is the derivative of whatever y is. Well, we don't know, so we're just going to have to say, all right, it's the derivative of y. Then the chain rule tells us to take f prime of g, so cosine of x with y plugged in for x. In other words, cosine of y, and then take that times g prime, which is dy dx. All right, so let's pause for a second. We won't go through this chain rule process every single time we have to do implicit differentiation. Because what is the derivative of sine? It's cosine. Derivative of sine y is cosine y. The only difference is, and this is literally the only difference, every time you take a derivative of something that's got a y in it, you're going to have to multiply by dy dx at the end. Other than that, it's going to be the same derivative as it would have been if it had been an x. So sine y becomes cosine y, tack that dy dx on the end, and you're done. All right, so now our goal was to find dy dx, so we're just going to solve for this thing right here. We're going to solve for dy dx. So since it's multiplied by a cosine y, we will divide by that cosine y. And there's our answer. We may want to change this, although there's nothing wrong with leaving it the way it is. 1 over cosine, the reciprocal of cosine, that's secant. So whether you say it's 1 over cosine or you say it's the secant of y, either way, that's what dy dx is.